So, hello everyone, hope you're doing good and welcome back to our channel. Today we are at the day 18 of the June Daily Leetcode Challenge, and we again have a hard level question in front of us. Let's see what the question is. It's a really interesting question. There are many ways to it basically, but there are some limitations in each of the approaches which you take, and that's why we will get to know how the optimal approach is reached. I see. Whenever you see a hard question, the only thing which I want to tell you is that you have to learn something new from it at least. Okay, don't expect this kind of questions in an interview setup, especially if you're a fresher. But definitely, I will say one thing that you should learn something from it. Okay, because these ideas what you are getting from a hard level question will definitely help you a lot. In solving medium level questions. Okay, and let me make it very clear. Medium level questions of lead code are the ones which you will get in interviews, in real interviews, even in companies like Amazon and other companies. These kind of questions will be coming. Okay, and obviously, I'm not saying coding is the only thing which will be asked in interviews. Obviously, there are system designs and other things also. But when we talk of coding, these level of questions will be coming, which are of medium of lead code. Okay. When we talk of medium, there are two kinds of mediums in lead code: the easier side ones and the ones in the higher side. Okay. So definitely you have to be careful with both of them. But coming to this question, it's a hard level question. You after seeing this question, definitely you should have something learned out of it. Okay, that's the only aim while solving a hard question in lead code. Okay. So it's question 2 3 number of increasing paths in a grid. Okay, number of increasing paths and grid. So let's see the input first. We can clearly see we are given an input. Okay, it's called a grid, and it's filled with numbers. Okay, let's see the dimensions here. So okay, both m and n. See, one thing is very clear: m and n are not same. Okay, it's not a square grid. Okay, m and n need not be same. That's one thing, and it can be up to 1,000 cross 1,000. Okay, so that's one thing. And let's see now what is the question. Okay, so we are given n cross n grid metric called a grid. Okay, it's a matrix called grid where you can move from a cell to an adjacent cell in four directions. Okay, please make this point very clear. What do you mean by four directions? Okay, so in typically see, when we talk about directions, there are eight directions. Okay, for example, see, if there is a better example. Okay, this is the only grid given here. Okay, so what can happen? See, suppose I'm a three. Okay, I can either go to one, which is the vertical direction, or I can go to four, which is the horizontal right direction, or I can go to something below three, which is the bottom direction. Okay, vertical bottom direction, or I can go the left of three. Okay, so it's the left horizontal direction. Okay, these are the four directions which basically they are talking about. Okay, in this question we are going to take these four directions. Please pause the video, go 5 seconds back, and rewind again what I said. Okay, it's vertical top and bottom, it's horizontal right and left. Okay, these are the four directions we talk about in this question. Okay, but typically when I see, from my experience I'm saying this, whenever I see grid question, typically what happens is that they may give eight directions also. So what it means, see, suppose I'm a three, I can go to the diagonally, this one which is connected diagonally. Okay, that way also we can do. Similarly, if you talk about the other four possible diagonal elements, so it can be four. Okay, so four diagonal elements plus four elements which we can reach to vertical and horizontal directions. So total there are eight directions. But in this question, we are going to talk about four directions only. So if you get a similar question in eight directions, you just have to make a difference in your directions array. Okay, I will talk about this later. But yeah, just remember these things matter a lot. Okay. So yeah, coming to the question again. Yeah, these are the four directions. Okay, return the number of. So what is given is that we can move from a cell to any adjacent cell in all four directions. Okay, so one cell from one I can move to three, from one I can move to one. Okay, from this one I cannot move to four. Okay, because it's a diagonal and they are not considering the diagonal directions. Okay, now coming to the question, return the number of strictly increasing paths. Okay, this word is being highlighted here. Please understand this word clearly. Okay, strictly increasing paths in the grid such that you can start from any cell and end at any cell. Okay, so, but one thing is very clear. See, this is not a table kind of question. That's why it's hard. Like, see, why it is hard means, see, they have mentioned it can we can start from any cell and at any cell. Okay. See, normally what will happen is that they will ask us to start from the 0, 0 cell and enter at the bottommost right cell. That kind of question will be in the medium level question. But in this question, they have removed that condition also. So here we do not have any end. Okay, any start. You can start from any cell and end at any cell. Okay, so what? See, let us not focus on this statement. Okay, this statement is a typical statement. Okay, so what happens is the answer will be large. So they are trying to make it short by doing some modulos. So modulo means we are taking the remainder when we divide the answer with this number. Okay, so that is something typically happening in almost every hard question in lead code. Okay, let's not consider that. Now comes the important part. Two paths are considered different if they do not have exactly the same sequence of visited cells. Okay, same sequence of visited cells. So, for example, see, 114 is different from 113. Okay, That's what it is. So what, see, same sequence of visited cells. That means if I visit a cell, then I see the if you calculate all the cells which are visited, they should not be same for two paths. Only then the two paths will be considered different. Okay, that's the basic idea. I know this statement is a bit ambiguous, but we will find it. When you see the example, this will become very clear. Okay, so please hold on for this statement. Now coming to what is steadily increasing. Okay, so in many questions of June itself, June daily code challenge itself, these things we have encountered, and I've explained a lot about this. So see, steadily increasing, what it means is that, see, for example, 1 comma 1. Okay, if suppose there is array and there are two elements 1 comma 1, then it's not strictly increasing. What it means is, see, always the ith element should be greater than the I minus one element. Okay, that is what is meant by strictly increasing. It cannot be equal. That is the basic idea. 1 comma 1 means they are same. It's not increasing. So the idea is when we move from one element from the left to the element in the right, that should be some increase. Okay, that's what is meant by strictly increasing. That means the equal elements cannot be considered. Okay, for example, 1 comma 1, if I move, then it won't be counted as a valid path here. Okay, so that's what, see, they're mentioning paths. Okay, so it will not be mentioned as valid path because from 1 comma it's not increasing. But if I talk about 1 comma 3, definitely it's increasing path. Okay, if I talk about 1 comma 4, it's definitely increasing path. If I talk about 1 comma 3 comma 4, definitely it's a strictly increasing path. Okay, that's what it is. But let us quickly jump to the example, because these kind of definitions, three definitions, don't convey much. Let's see the example. So yeah, what are the increasing paths? See, first of all, because there is no start and there is no end. Okay? They have not mentioned what can be the length of the path. That means even a single element will be considered as a path. Okay. So for example, one, then another three, and then four. Okay. So the path with length one, you can see each one of the elements itself. Okay. Now coming to path of length two. Okay. 1 to 3. Okay. 1 to 4, then 3 to 4. Okay, these are the some of the paths with length 2. Okay, 1 to 3, 1 to 4, and 3 to 4. Now coming to path of length 3, 1, then 3, and then 4. Okay, this is the only path with length 3. So how many paths we have? This is 4 plus 3 7 plus 1 8. Okay, 4 plus 3 plus 1, which is 8. Okay, so that's what it is. That's the answer. Okay, we have to return the number of paths as the answer. But if the number is a bigger one, we have to do the modulo by this also. So I hope you have understood the questions, and yeah, you can go to example through on your own. But let us see what to do in this question. So I am making this very clear. We are going to solve it using the dynamic programming approach. Okay, let's see how we are doing that. Before solving that, there are some ambiguities here. We have to clear that first, and then we'll solve the question. But let me just show you how we are doing it using the data structure. Okay, so what we are doing is, see, basically we are talking about a dp array which we are going to use. Dp will look exactly same as the grid. Okay, so the dimension of the grid will be exactly the same which I will be using for the dp. Okay, so dp is also going to be a two-dimensional matrix which will having the same length as that of the grid. Okay, so dp of the same size as the grid to present the number of paths that end at each of the cells. Okay, for example, if I talk about dp of 1 comma 0, that means it will dp of 1 comma 0 will tell me the value in that dp of 1 comma 0 will tell me the number of paths that end at 1 comma 0 index of the grid. Okay, I hope this thing makes clear sense to you. We use dp. So what is dp? It's a two-dimensional matrix which I'm going to use. Okay, I'm going to do the dynamic programming through this. Okay, this array, it's a two-dimensional array. It will be of the exact same dimension as that of the grid. What is grid? This particular given input is the grid. Okay, it's called grid in this. Okay. Yeah, to represent number of paths that end at each of the cell. Okay, so for example, when I talk about, see, this element is called 1, sorry, 0 comma 1. Okay, this one which you're seeing here, no, it's called 0 comma 1. Okay, it's ended as 0 comma 1. So when I talk about dp of 0 comma 1, it will tell me number of paths means what, that this path, I am referring to this particular path. Okay, what is mentioned in this question? So number of such paths ending at 1 comma 0. Okay, that will be the value of dp of 1 comma 0. Okay, so initially the value of each dp of I comma j, of each element in this dp array will be 1. Why? Because we are seeing here, right, we are seeing here that each element in itself is a path. Okay, that's why its value will start from 1. Okay, stands for the path made by grid of I comma j cell itself. Okay, yeah, so I will just show you how it works. Okay, so see, here we are discussing some of the valid paths. Okay, for example, see, 1 comma 1 is not a valid path. Similarly, 4 comma 3 is not a valid path. Okay, because that should be increased when we move from one element to the next. Okay, now, yeah, this is how the dp array will look initially. Okay, so you can see its dimension is exactly same as that of the grid. Grid is basically the input given to us. Okay, it's called grid. It's the matrix given as input to us. So you can see dp initially is having all the numbers as 1. Okay, now we'll start the process of getting the answers. Okay, so for that, now try to understand this question. Please pay attention here because these things are very logical and you will get this that is only when you see. Okay, this is what I want to learn basically from this question. See, suppose I am having the number of ways, so the number of paths that ended at 3. Okay, suppose I am given that. Okay, now talk about 4. Okay, see, 4 is greater than 3. One thing is very clear. Okay, that means whichever path ends at 3, it can be extended to 4. Okay, is I hope I am getting, making it very very clear. I have the number of paths that end at 3. Okay. Suppose we have that. Okay. Now, when we talk about 4, 4 is greater than 3 and it's adjacent also. Okay. So, all the paths which end at 3 can be extended to 4. Okay. But it need not be the only source of paths for 4. Okay. Paths from 4 can come from this one also. Okay. So, what I'm saying is, whatever be the path at 4 from other sources, but we can add all the paths that come to 3. Okay, what that means is what we are going to do. That's what I'm writing here. See, let a grid of I plus 1 j is larger than grid of I comma j. Okay, so you can see I plus 1 j is basically adjacent element of I comma j. Okay, it means every path that ends at I comma j can be extended to I plus 1 j. Okay, therefore what we'll do is we will add the value, sorry, not grid, it's basically the dp value. dp value of I plus 1j is plus that means dp value of I plus 1j, we will add to this the value of the dp of I comma j. Okay, see what dp of I comma j represents. It represents all the paths that ended I comma j. Okay, but we can clearly see that all the paths can be extended to dp of sorry, the I plus 1 j index also. Okay, so the same thing we will add here. Okay, this whole value we will be adding to this value. Okay, so please pause this video and remind some 10-15 seconds later what I said, because I see I am trying to my best to make sense. Okay. See, all the paths which ended 3 can be extended to 4. The what that means is I suppose I have this thing. Okay, what is this called? It's called dp of I comma j. Okay. This will be added to the dp value of this. Okay, that is dp of I plus 1 j. Okay. That's what we are doing here. dp of I plus 1 j plus equal to dp of I comma j. Okay, so this thing can be done, but see now the question is in what order they should be done. Okay, I will trace and show you one example here. Okay, see, suppose I am at 3. Okay, suppose, yeah, see, this whole thing is given. I am initializing all the values with 1 comma 1 like this. Now I'm going to start. Let me pick 3 first. So what are the elements greater than 3? Definitely 4 is the element greater than 3. Okay, initially what is the value of dp of 3? Dp of the index which has 3. Okay, it is 1. Okay, so I will just add 1 to the dp value of this element. Okay, so what is the dp value of this element? It's 1. Okay, so what will this value will become? It will become 2. Okay, but now suppose I have done that. Okay, later, but now I come to this one, and because of this one the dp value of this element will again increase. Okay, what it means is, see, this value, the dp value of this index, see, please trace my mouse pointer. See, dp value of this index is already added to 4, but later we got to know that 1 is also smaller than 3, so this value will also, the dp value of 1 will also be added to dp of 3, but we know that 3 dp value of 3 is already added to dp of 4. Okay, that is one instance which shows us that there should be a definite path. Okay, you simply cannot randomly start from anywhere. Okay, that's where the idea of sorting comes here. Okay, see, dp of 1 will be added to dp of 3 because 3 is greater than 1. Okay, what it means is we will start from smaller values and then we'll go to bigger values. Okay, for example, we'll cover all the smaller values like 1 first, then we'll go to 3, and then we'll go to 4. That is the basic idea which we are going to follow. Okay, so here we need a sorting. That's what we are trying to say. And then see here that what happens is, see, first I will finish this one first. Okay, so I will finish this one first. So what are the addition elements for this one which are greater than 1? Okay, so we can see the only 3 is the one addition element which is greater than 3. Okay, so the dp value of this will be added to this. Okay, so this was 1 initially. See, here it was 1. Okay, but this one also got added to it, so it become 2. Okay, yeah, now we'll go to the next one. Okay, see, yeah, we're going to the next one here. Then please find any element which is greater than this one. Okay, adjacent to it. So we can clearly see 4 is the only element which is adjacent to it and greater than it. Okay, so what we'll do, we'll add the dp value of this one to the dp value of this. Okay, so you can clearly see the dp value of 1 was also 1, dp value of 4 was also 1. Okay, so what we'll do, we'll add this 1 to the dp value of 4. Okay, so it becomes 2. Now please see the scenario here, both are 2. Okay, now next we'll go to 3. Okay, please find the adjacent elements of 3 which are greater than 3. Okay, so only thing is 4. So we'll add the dp value of 3 to the dp value of 4. So this 2 will be basically added. Sorry, not, yeah, this 2, this 2 which was single will be basically added to this 2. Okay, that's what will happen next. So yeah, you can see now this became 4. Initially it was a 2, but the 2 which represents the dp value of 3 will also be added to this. Okay, Yeah, it became 4 here. Now we'll come to 4. Please find any adjacent element of 4 which is greater than 4. There is none of the elements, so we will not do anything. Okay, we'll just simply leave it like that. Okay, and finally, we are getting the DP value like this. Okay, so this DP value will tell me. See, for example, this one tells that number of paths that enter this one. Okay, this element. So this value tells the number of paths enter this element. So this all of them will represent some paths. Okay, end of some paths. Okay, finally the answer will be addition of all these elements. Okay, so the answer will be 4 plus 2, which is 6, plus 1, which is 7, plus 1, which is 8. Okay, so 8 is the final answer, and we can see here that 8 is the final answer. That's what we're trying to do here. Okay. So I hope you are getting some idea here, but definitely I won't expect you to get it in first attempt. Please pause the video and remind it again and again till you get the answers. Okay. See, I have tried my best to include each and every point in whatever I'm saying. Okay. I really prepared hard for it. So I definitely expect you to get this maybe in second attempt or third attempt. Okay. So now coming to the code. See, as I clearly mentioned, this input is not a square matrix. So M and N will be different. Okay. You cannot take a single element for it. Okay. So M will represent the basically the vertical dimension, and N will represent basically the, so that is, see, M will be the number of rows. Okay. N will be the number of columns. Yeah, that is all. Then we are taking mod as this particular number. Okay, which they mentioned in the question, this thing. Okay, 10 power 9 plus 7. In Python, when you do two stars, it basically means raised to the power. Okay, that means 10 raised to the power of 9 plus 7. Okay, then comes the dimension side, sorry, the direction side. See, there are two. See, for this will represent that we are moving 0 times vertically and 1 time horizontally along the positive x direction. So it basically means a movement towards the right side. Similarly, this means a movement towards the left side. What it means, see, we are moving 0 horizontally, we are moving 1 along minus 1 along the positive x axis. It means we are moving 1 along the negative x axis. Okay, so this will move, this will mean a movement along the right. This will mean a movement along the left. This will mean a movement along the top vertical. Okay. This will move. Sorry, this will mean a movement along the vertical direction along the bottom. Okay, a bottom vertical direction. Okay. Now we will initialize the DP array as I mentioned. It will have the same directions as that of the create. Okay. So that's what we are doing. See, it will initialize with one. Okay. So it all the values in it will be one initially. Okay. So this is what it is. It will be one initially. Then see, this will represent the row basically. It will represent each of the rows. Then for each row, we are this is will be one row. Then we are multiplying it with number of rows we need. Okay, this is what we are doing. Okay, this will be representing one row, and we are then multiplying it with the number of rows we need. Okay, so it will copy it. Okay, then we are doing the basic sorting function. Okay, so first, see, we are creating, see, the sorting will be based on, see, what we need sorting basically. First, we need to know, see, it's all about index. Okay, as I mentioned, we are going for the indexes. Okay, here the index matters here. Okay, so what we're doing is we are going to create an index list which will basically have the indexes. Okay, only the indexes. See, this is only creation part. Okay, still now we have not started the sorting. Okay, this is called the index list. What it means is we will be storing the indexes. Okay, for example, I comma j. I represents the row number. I represents the row number. J represents the column number. So if you combine both, you will get a single element. Okay. And if you know the row and if you know the column, you will get a single element. Okay. So this is what is being done. And we are storing them as I comma j. Okay. But while sorting them, see, initially it will be like 0 comma 0 0 comma 1 0 comma 2 like that. Okay, then 1 comma 0 1 comma 1, like that it will be. Initially the index list will be like that. Okay, but when we are sorting it, how we are sorting, we are sorting it based on the values and not on the indices. Okay, for example, this element is 0 comma 0, this element is 0 comma 1, this element is 1 comma 0, this element is 1 comma 1. But while after sorting, it will be based on the values. Okay, that's what we are trying to say. So the sorting will be based, see, the indexes will only remain like that only, but remember they will sort it based on their values. That's what we're doing. Grid, see, we are trying to define the grid here. Okay, this is the input. We take, see, the first one is the axis of 0. What is x represents each of the elements in this grid. Okay, so this is what we're trying to do here. See, if you try to understand this in detail, see, this represents the row number, this represents the column number. Okay? And x represents the any random element. Okay, out of this. This is what we're trying to do. Okay. If you talk about x of 0, basically, it refers to the I. Similarly, the x of 1, basically, it refers to the j. Okay. So this is particular things I'm saying because I'm expecting that a beginner will be watching this video. Okay. Otherwise, these things are not needed. Okay. Then we will start the directions thing. Okay. Now, see, this I comma j we showed, right? These are now sorted. Okay. So what we're doing is I'm now going to go to the I comma j of the sorted list. Okay, this is the sorted index list. Okay, then I will be adding the directions to it. Okay, see I comma j is the index of my current element. For example, the current element one. Okay, now I will be adding these directions to it. Okay, see if I add these directions, I will get its neighboring element. Okay, so for di comma dj, which refers to the change along the other direction, then change along the j direction in directions. This will refer the current I comma current j. Okay, current I and current j, please make this one very clear. This you will use in many questions. Okay, current I and current j basically refers to the adjacent elements of the I comma j. Okay, there will be four current I and current j for each of the I comma j. Okay, that's what I'm trying to say here. So current I comma current j refers to the adjacent element. Okay, this please understand very clearly. It will be adjacent element. Okay, so what I'm doing for the di, I'm adding the I here. Okay, similarly for dj, I'm adding the j here. Okay, remember this element may or may not be existing in the current grid. Okay, for example, if I talk about one, you can see there are four possible neighbors for this one. Okay, out of that, the left one and the top one are not even in the grid. Okay, only the right one and the bottom one are in the grid. Okay, that's what we are checking here. If the current I, that is the I will repeat again, current and current j basically refers to the adjacent elements. Okay, I'm checking here if the current I is within the grid. Similarly, the current j, see, this refers to the column number. Okay, current the column number is within the grid. Similarly, the row number is within the grid, and the column number which is represented by current j is within the grid. See, only if it's within the grid, then it will refer to a value, right? We are checking that. Now if these 2 points are okay, that if it satisfies these 2 points, that means if it's a element inside the grid. Okay, if it's an element inside the grid, then definitely it will have a value. That's what we are trying to check here. Okay, if the value of the current element is greater than the existing element, that is the I comma j element. Okay, the that means if the neighboring element has a value greater than the current element, only then that's what we are doing here. We will add the all the paths that end, and this we will add it to here. Okay, see the number of paths that end at I comma j will be added to its neighbor now. Okay, that's what we are doing here. The dp value of I comma j, that is, it represents the number of paths that ends at I comma j, will be added to its neighboring element path. Okay, so this dp of this neighboring element refers to number of paths that will be ending at this deep current this neighboring element. To this value we'll add the neighboring this neighbors number of paths. Okay, that's what we're doing here. Okay, remember this being done in a very sorted way. Okay, that means there won't be any overlaps here. Okay, as I mentioned in the article itself, there can be cases where we have updated a value already, but then the value is changing. If we sort the list like this, there will never be a case like that. Okay, that's what we're doing here. And at every instance we have to do this modular thing. Okay, we are dividing. So what it means is we are taking the remainder. Okay, we are not storing the whole value. Basically, we are storing the value after doing the model. Okay, that is, we are storing the value after. That is, we are storing the remainder after doing the division with this particular number. What is this number? It's coming from here. 10 power raised to power 9 plus 7. Okay. And finally, we'll take the sums. Okay. Sums we'll take row wise. We'll take the sum of the whole row. Then we'll do a modulo. And then see, like this we'll do for all the rows. Finally, when we are taking the sum of all these rows, we'll again do a modulo. Okay. We'll again repeat. This is the sum of each rows. Okay. We'll take the sum of the whole row. Then we'll do a modulo. We'll take the sum of the second row. We'll do a modulo. We'll take the sum of the third row. We'll do a modulo. Then the sums will be added. Then we again will take a modulo finally. Okay, and that answer will be returned. I will quickly run and show how it works. In case it's clearing the test cases. So yeah, friends, that was all for today. I know this was along the hard side, and its time complexity is also a bigger one. Okay, but still, I hope you will get something to learn from it, and especially these direction things. Okay, these things will be used in every BFS DFS solutions. Okay, please be bit familiar with these things. That's what I would expect, and that's what I will set a target for myself as well. Okay. So yeah, friends, that was all for today. See you tomorrow. Thanks a lot.